One problem with a traditional silt fence system is the method of attachment. The filter material does not have the structural strength to stay attached to the supporting system, whether that system is a post, grid, or wire-back system. The weight of the stormwater and sediment will tear the filter material from the support system. In some cases, the wind is strong enough to remove the filter material from the support system. There is another excellent feature for the woven line of silt fences by Silt-Saver. That feature is WBSF. WBSF stands for Woven Belted Silt Fence. The WBSF line of silt fences solves the problem of weak attachment points by using 350-pound tensile strength belts as attachment points to wood posts and metal posts. All three woven fences made by Silt-Saver have WBSF technology. Each of the woven-in belts will support a minimum of 350 pounds tensile strength. The belts are used as attachment points and linear support for the system. Woven-in belts act much like highway median cable barriers. If there were no cables tying the posts together, a truck would hit the post and knock it down. The truck would end up in oncoming traffic. The purpose of the cables are to tie the posts together, dispersing the weight of the vehicle between all the posts, not just one. The system can now stop semi-trucks. The belts in the WBSF line of products act much the same way. The woven-in belts tie the posts together, so when the weight of the stormwater and sediment press against the fence, the weight is dispersed to the whole system, not just one post. This allows the system to hold much more weight. We have created a visual demonstration that shows how well a silt fence system will hold back sediment. This device shown simulates the post being driven into the ground being the metal braces. The silt fence material is then attached to the post using recommended attachment methods. Weight is then applied to that system until the system fails.
This system is a multi-component system. Failure of any one of these components is a failure of the total system. We've tested the fabric, but we've never tested the structural element of the fence. We're going to take this same apparatus now, we're going to turn it around, and we're going to load 100 pounds at a time until we get to a point where we think we won't carry 100. $300, $400. If you notice the post on that side, it's already bending. We're going to try another 50 pounds on that. It's falling in at 450 pounds. We had failure at 450
Please pay
pounds.
attention to the picture in the top right hand corner. This is a still shot taken from the opening video of this PowerPoint. Please note how the metal post is bent exactly the same way that the system failed in our wire back weight test. This is a real-life example of a wire back fence failing.
It's called Woven Belted Silt Fence. It has an internal belt woven into the fabric, adding linear strength at various points across the fabric. This also gives you an attachment point on your post for your staples or whichever manner you choose to put it up. Each one of these bags weighs 60 pounds. $360 pounds. $540 pounds. 600 pounds. $1,020 pounds. Let it go. 1,080 pounds we're losing. Thanks for your time. I hope that proved a point that you've got to have a system approach. Every component has to be strong.
The previous demonstration is not an official ASTM-D test. It is just a simple demonstration. We do have ASTM-D testing that supports the strength of our material. The wide width tensile test ASTM-D 4595 takes an 8-inch section of the silt fence. This 8-inch section only ends up being 2 of the 4 belts that are woven into the WBSF line of silt fence. The material is then put on a machine that pulls the fabric until it breaks in half. The point that it breaks in half is called the ultimate strength. This test, when performed on the WBSF 2 stage, gave an ultimate strength of 3,732 pounds per square foot. Remember, this test was performed on only 2 of the 4 belts that the 2-stage silt fence is woven with. Woven-in belts offer strength and attachment points and linear strength, creating a strong support system for your perimeter control.